Hi students, if you're watching this video, you've already watched drawing of basic Lewis dot structures, and you've also watched formal charges and how to calculate that. And in the Lewis dot structure video that I went through and followed the basic rules, we basically ended up with two possibilities for CO2. So I'll just go through it really quick. Rule number one, determine the central atom and count the total valence electrons. Carbon is group 4, so it has 4 valence electrons. Each oxygen has 6. 6 times 2 is 12 plus 4. I have 16 valence electrons. I know carbon's the central atom. It's a central atom because it's more electropositive. So I go, and the first rule is I got to attach to the central atom the outer atoms. So I used up 4 electrons because each bond has 2 electrons. So I only have 2 valence electrons, or 12 valence electrons. So I add them to the outer atoms to satisfy their octets. So I add them to the oxygens, subtract 12. There's no more. If there were any left, I'd attach them to carbon, but there isn't. So at this point, I have a couple choices. And we did this in the last video. I can take one here and put it there, take one here and put it there, and then I would have this structure. Or, let me get a different color so it makes a little more sense. Or I could just pick one of the oxygen and add the lone pairs to both of those to give carbon the central atom an octet, and I would end up having this. And in that earlier video, I had mentioned, because that video was geared towards preparatory chemistry, that this one is the preferred structure just because it looks symmetrical, right? 2 bonds for each oxygen, and it's it's symmetrical, it looks happier. And I did use the bonding patterns that oxygen likes to have 2 bonds and 2 lone pairs. Well, now we can use step 4 of those rules I gave you for general chemistry. And in step 4, we choose a Lewis structure that has the lowest magnitudes of formal charges. So if we look, this carbon right here, it has 4 bonds, so its formal charge is 0. And that goes back, if you watched my earlier video, right? It has 4 valence electrons, and I'm going to subtract the number of bonds. So 1, 2, 3, 4. So that means that this carbon in this structure has a formal charge of 0. Now the oxygens are equivalent. So if I figure out the formal charges for the oxygens, I take, again, the number of valence electrons. Each oxygen has 6. I'm going to subtract basically half the electrons in each bond. Each bond has 2. Half that is 1. Just count the number of bonds. So I count this oxygen, right? It has 1, 2, 3, 4, 5, 6 valence electrons, and it has 1, 2 bonds, right? And then how many electrons in lone pairs? 1, 2, 3, 4 minus 4. That means each oxygen has a 0 formal charge. That's why this is the preferred structure. Carbons and oxygens in this structure have a 0 formal charge. If I come over here, the carbon still has a formal charge of 0 because it has 4 valence electrons, right? 1, 2, 3, 4, and it subtract the 4 bonds. 1, 2, 3, 4. It's 0. So carbon has 4 bonds, it's 0. So that's not what determines it. What determines it are the 2 types of oxygens and their formal charge specifically. And now I'm going to use a different color to kind of show this. If I look at oxygen A and I try to determine the formal charge, 6 valence electrons. Okay, how many bonds? 1, 2, 3. Minus 3 bonds. How many electrons in lone pairs? 1, 2, minus 2. 6 minus 5, that's a plus 1. Ooh, This oxygen has a formal charge of +1, and oxygen hates that. Oxygen never wants to have a formal charge of a positive value. It's extremely electronegative. Now, you sometimes do see oxygen having single bonds. And why is that? Well, if we look at oxygen B here in this structure, so we'll go oxygen B, right? What does it have? 6 valence electrons. How do I know? Well, 1, 2, 3, 4, that's 5, 6. It has 6 valence electrons because it's in group 6A. And then how many bonds? 1, minus the number of electrons in lone pairs, 2, 4, 6. It has a formal charge of -1. So this structure for carbon dioxide is a valid Lewis dot structure, right? It's also called a resonance structure. Now, it's not an equivalent resonance structure, but it is a resonance structure to this. However, it is not the preferred Lewis dot structure because of rule number 4. And rule number 4 is you choose the Lewis dot structures that have the lowest magnitude of charge. So even though this structure +1 -1 gives me the neutral compound of CO2, because +1 -1 cancels out, it doesn't have the lowest formal charges. This one does, because oxygen has the preferred formal charge of 0 with 2 bonds and 2 lone pairs. So that explains using step 4, how to determine the lowest magnitude of formal charges in a Lewis dot structure to pick the preferred structure. So I hope that helps. Stay tuned for step 5.